First of all, thank you everyone for coming today. I really appreciate you spending your Friday night listening to this. Um, I guess I'll introduce myself. My name is Natalie Shank. I'm a senior in mechanical engineering, and I am this year the chief engineer of UR Baja. So the idea for this PDR is, unfortunately, I will first also apologize for all the emails that I've been sending, but we want to do kind of an intro to a design review for our team this year. And then because of timing, we're going to have to push the subsystem level PDRs to the week after Thanksgiving. So after this meeting, um, I will send out a schedule for all of that. And then hopefully it works out. I've shared the information for all of those of you who have filled out the form to the subsystem leads. So they'll try to plan around their schedules as well as the people who have expressed interest in the different subsystem level PDRs. But yeah, so I just wanted to start off by saying thank you for coming. And also I apologize for the emails and I will now start the PDR. Um, okay, so I'm going to start with team structure just to get everyone on the same page. So this year I'm the chief engineer. Aiden Dubin is our chief mechanic, and then Ruby Perkis, who is sitting next to me, but you cannot see, is our president. Yeah, so she just popped her head in. This year we've structured the team a little bit different. So I'm in charge of the design board and systems. So we have Eric Begashev as systems integration and Khan as testing and validation. Ruby is in charge of the executive board, which includes me and Aiden, and also Reese Donnelly, our marketing director. So for those of you who've seen our new newsletters this year, Reese has been in charge of that. They've done a really good job, and they're trying to revamp the website as well for the team. George Baltus is our operations director, so he's in charge of all of the funding for the team and also acquiring sponsorships. Aiden, as a chief mechanic, is in charge of all the manufacturing, as in previous years. But if you remember from last year, we have a pretty established welding team now. So Ella Petticord is our chief welder. Ava Burke is our fixtures lead. And then Cass Garibaldo is going to be our suspension manufacturing lead, as well as the person in charge of new member training, which is something that we brought up this year as well to kind of work on member retention as well as the knowledge transfer from the upperclassmen to the freshmen and the sophomores. So to continue more for design board specifically, which is relevant to this design review, and then also all the subsystem preliminary design reviews that you'll be seeing over the next couple of weeks. We have a drivetrain team. So Ella Young and Jonathan Wu are the drivetrain team leads this year. And then we have a power distribution project team lead, Bryce Sabin, and our transmission or CVT project team lead, Lucas Sabatini. Our suspension team is composed of Miles Owens, our suspension team lead, Giovanni Marie Cruz. Sorry, I wasn't gonna read your full name, but he's our brakes PTL. Lynn Quat is our steering PTL, and then Andy is a new member on our team who's been working with the suspension team. Our frame team is just Benzir Rida. We're working on that right now, but she's also a welder, and she collaborates a lot with the welding team, as well as Ava Burke, who's in charge of our fixtures. Our ergonomics team is composed of Miriam Heater. So she's in charge of everything the driver touches, the seat, the positioning of the driver in the car, electronics and data acquisition. So Sienna's in the meeting right now. She's the data acquisition team lead. And then we have another senior on the team, Liam Knott, who's been working with her on the microcontroller stuff. And we have a huge electronics team, which I'll talk about in a second. But yeah, that's the breakdown of our team right now. So under me directly, there's only 5 people, but then there are leads that manage all of the projects as well. Okay, so main team status updates that I could think of over the past few weeks that are kind of relevant. So we talked about expanded design and manufacturing teams. We've tried to organize in a way that helps us to streamline this contact path between all of the members, as well as kind of streamline how we manage all of the projects on the team. So one big thing that I don't know, maybe Sienna can speak to this at the end, and parts of her projects are going to be involved in all the subsystem PDRs as well. But we have a larger data acquisition team this year. So there's a lot of freshmen and newer members that have been working on smaller projects, which either integrate electronics or are directly working with the data acquisition process. We have weekly marketing and operation team meetings, which are much more involved and also involved with the team specifically. So each of the subsystems are required to kind of establish sponsors that they want to reach out to every year. But we have general marketing and operations goals that we're also trying to meet as a team to kind of build up our public stature a little bit more. Previously, in like the past week, we've reestablished contact with RIT to update the contract that we've been using for their track use. So we figured out a way for someone on our team to be in charge of that now, and we're going to be utilizing that a lot over the next couple of months and in the future as well. And we've also been regularly using our track on campus, and facilities has given us access to more of the back part of Genesee Valley Park as well. I talked briefly about updated newsletters with team member activities and updates on the organization activities. So any of the social events that we're involved in, outreach, as well as design updates or competition updates, those are all in newsletters. So for any of those of you that don't have access to this newsletter, at the end, I'll probably bring it up again just so that we can get your name down and then we can put you on the mailing list. But I just wanted to update that to everyone if you're looking to see kind of information on a monthly basis about what our team is up to and what our plans are or what the big goals and deadlines are. That's a great way to check that out. And then the other thing I wanted to highlight is that this year we're trying to establish an allocated budget to research and development. So that includes like smaller projects, whether they're involved in manufacturing or whether they're research projects for things on the team that we're trying out for the first time. So more status updates. This is kind of copied over from last year. Manufacturing, these are still like the main processes that we use as a team and we've had some more access to. For design, we're still using Siemens NX and SimCenter 3D Motion for mechanism models and dynamic models. This year, I think is the first time we're really like trying to use Kissoff for drivetrain like gear calculations. So that's been a new sponsorship that we're looking at and people have been utilizing on the drivetrain team. And then we've changed over. I just realized that this is bolded and some of it's not bolded, but we've changed over to part management on an external server that's connected to the university, but not on Teams or Kinesto. So that's really helped a lot with trying to manage the organization of the parts as well as making sure that there aren't conflicting parts or people have updated things. And then the main big thing that we're trying to work on this year is just like streamlining and organizing the manufacturing and design process in a way where there's communication across the board. So in terms of design and then the actual like realization of design, there's been a lot more coordination between fixture design and the welding team. And Con updated everyone on this last year, but the welding team is also a part of the design board conversation. So we've really tried to integrate everything together instead of having them separated. So to update on the 2025 competition attendance, we attended the Baja SAE Arizona competition in May of 2025. So we flew over there. I think this was briefly mentioned in the PDR last year, but part of our decision to attend the SAE Carolina competition in October, at the beginning of October in this semester, was dependent on a performance in Arizona. So as most of you might know, we normally attend Octo Baja, which is an unofficial competition hosted by Clarkson University. But this year we decided to attend a second official competition to run the car one more time and then make modifications on that as well, especially since a lot of our members were here and available over the summer working on the car. So it was just another way to kind of get the real competition experience and then also build up that confidence that the people on the team can kind of manage multiple competitions in a year. Whether or not we continue that in the future, I think in the fall of next year, we're planning to attend Octo again. But I think we're off to a good start, having said that this car has attended two official competitions. So that's where we're at right now. And then also for those of you who may not know, we're attending the SAE competition in Rochester, in New York, in June of next year. So for those of you that are local, I think I mentioned in an email that, or maybe it's in at the end of this presentation, but please reach out to Ruby if you're interested in volunteering or attending. Um, this is great because we're going to have anyone who's in Rochester or kind of around the area attending this as well. So it's a good opportunity for new members that are going to be here over the summer. And also for those of you who are alumni, I think Ruby has a contact for people who would be available to contact if you wanted to volunteer for the event as well. Okay, enough of that. So competition results. This is with our current vehicle. In South Carolina, our overall rank was 24 out of 66. I'll be talking about the cost event later, but we ranked 49 out of 63. Design, 14 out of 62. Business presentation, 28 out of 65. Acceleration, 18. Maneuverability, we got a DNF. Sled pull, there was hill climb this year in South Carolina, and pilot pull or sled pull in Arizona. We placed 14 out of 43. Suspension and traction was 33 out of 40. And for endurance, we placed 22 out of 66. And I'll mention some of the things that happened there that are kind of like the driving factors behind what kind of decisions and processes we're trying to push for this year. So for competition debrief notes, I kind of just pulled out like the main major things, successes and areas of improvement that we kind of took away from all of our discussions here on our end. So this year we made 2 attempts at S&T. Last year in Arizona, we did not attempt S&T. That to me was really good for us. Even though we had some problems with like parts failing or getting dented during S&T, I think we're at a good place right now where we feel like we can push the car. So that I just wanted to highlight that. And then this year we only had some minor issues with tech inspection at the SAE Carolina event. So we're working on guarding. There's an R&D project that's in the works for body panels as well. So we're trying to work on the manufacturing process for that. Excuse me. So this year, one thing that we really tried to do as a team was prepare for design presentations as part of the new member training. We integrated a schedule to practice the design presentations and have all of the subsystem leads who are attending the competition present at least, I think it was over 3 times to the new members, which was really, really helpful. I think overall, I'm really happy with our performance in the design presentation. And this year also, we were really lucky that all of the Bay judges and also the subsystem specific judges were very eager and excited to share feedback to how we could improve. So we got a lot of good information from that. And then overall, this has kind of been a trend for our team, but compared to other events, good acceleration and traction event performance. And I'll talk about how we're trying to make that even better. Areas for improvement. So we struggled a little bit with CVT engagement and running a new belt, as we always do. But this year, what we're really trying to prioritize, and I'll talk about when we get to R&D, is tuning for different events and how we can have more confidence in our predicted performance. We had some problems with spare compatibility issues, so that's really one of the things we're trying to integrate into the schedule in the spring is testing all of the spares and having confidence that we've manufactured all of them with consistency to each other and also with consistency to how they mount to the frame. So overall, one of the main really big pieces of feedback that we got from the judges was that there's a need to kind of hit that threshold and get over the top 20, into the top 15 and top 10 for design. A lot of the teams do high level testing, mechanism models, vehicle dynamic models, and a lot of durability analysis is missing across all the subsystems and on a team vehicle level. So that's one of the things that I wanted to ask about at the end, if people had any suggestions or like any resources that we might be able to look into as a team. And then one of the things that I'm going to talk about that is one of our driving goals is predicting, testing, and validating different tunings and settings that we have for drivetrain and suspension. That's one really big thing that we want to talk about in terms of our goals for this year. So high priority adjustments before I get to like exactly what we're trying to do this year. As I hinted to before, we ran S&T twice and we did dent the frame. So Benzier, our chassis lead, is currently working on that. The tube is bent but only that tube. And they did let us run endurance the next day. So that was very lucky. Thank goodness. But what we're trying to view this as an opportunity to um, integrate and also kind of like solidify the way that we fixture the frame, just so that we can get into that habit and establish a process for the summer and the next year when we manufacture a new car from scratch. So for those of you who maybe have not heard about it in a while, we're still in the process of, manufacturing a new car from scratch every 2 years. So in Rochester, in the summer, when we attend that competition, we'll still be running this car, but the front footbox member will be replaced, and there'll be modifications based on this year's vehicle level goals. So yeah, we're trying to work with the resources we have in terms of the welding team, in terms of designing fixturing, and trying to reach that level of precision for the frame. That's what we're trying to use this as an opportunity for. And then the other thing was lower A-arm spares. We're out of all of those because we ran out of them during endurance. And so we're trying to address that fixture inconsistency to the tabs on the frame and explore new ways that we can mount points, whether that's inboard on the frame or outboard to, the uprights or whatnot, like the shock mounting tabs on the A-arms. And then, one of the questions we're trying to answer as a team is how do we accomplish higher accuracy with the plywood routed fixtures or with tab mounting? And that's one thing that we've really been focusing on this year. Okay, so getting into the meat of all of it, our customer vehicle level goals this year is to overall, in a very general sense, design a Baja vehicle that can reliably maximize performance across all the SAE competitions. So maneuverability, endurance, acceleration, hill climb, sled pull, S&T. So in the past, maybe we've only really tried to prioritize, getting the fastest car so that we can rank well in acceleration or robustness last year in terms of being able to complete laps in endurance. But this year, what we're really trying to attack is adaptability, which comes down to tuning the car for different events, especially maneuverability and acceleration maneuverability and suspension and traction in terms of suspension and steering. And then in terms of drivetrain, that hits acceleration, hill climb, and sled pull. So adaptability and serviceability are kind of like the two main reoccurring themes that we're trying to attack this year. So adaptability, I mentioned, was tuning the vehicle for different event conditions. And then one other thing is we want to make sure that these adjustments and tunings are measurable and validated and directly linked to performance outcomes. So they can be measured, whether that's in person through data acquisition, or we can model them in a vehicle dynamic model. And that's one of the things we're really trying to attack head on as a team, just so that we have more confidence in how we set up our car and how we predict that it's going to perform. Whether or not that prediction is true, we can worry about that later. In terms of serviceability, one of the things that I wanted to prioritize this year for the team and what we established as one of our goals was that we want to have components that can be easily repaired, adjusted, and disassembled consistently and effectively and efficiently. So that kind of goes back to like that fixturing consistency, and then it trickles down to serviceability of the components once they get assembled onto the car. Standardized interfaces, repeatable assembly, and compatibility with spares. That's kind of like a more specific example of how you can see that serviceability. And then one really important thing to us is, because we want to attack all of this tuning, whether that's suspension or drivetrain, is that we want to perform clearance and removal studies for the different components that require on-site tuning and adjustments. So whether that's the CVT or the engine, we really, as a team, try to prioritize having access to those things, whether that affects the guarding or how we structure the chassis around the internal components in the car. So that's one thing that kind of collects everything together on a system level, in terms of how the placement and the packaging of all of the vehicle components affect the chassis design and also how we mount things for the suspension. So vehicle level requirements, adaptability requirements, we want to talk about adjustable parameters and how they can must predictably affect I don't know what I'm saying. That they should be predictable, and we should understand how they're going to affect the vehicle performance. So again, I talked about this, but each of the adjustments that we make should be intentional, and they should be validated through analysis and physical testing. So through that whole cycle that the judges want to see of like validation, analysis, testing, and then like what do you do at the end with that? Do you go back and iterate on your design, or how much can you trust these things? That's what we're trying to hit in the full life cycle of every single design or every tuning that we choose for the car. So analysis specifically must quantify how all of these tunings affect, if they do affect load transfer, how they affect durability and how the car runs, and then also performance in each of the dynamic events. So one example could be like CVT tuning for torque versus acceleration. Like when do we want to choose one over the other? And which settings do we want to prioritize? How do we test those things? How do we model those things? These are all the driving forces for the kind of work that we're doing this year and we're hoping to do in the spring as well. In terms of serviceability requirements, so components must be easily accessible for adjustment and repair, clearance and removal studies that I talked about before. Fasteners and spares must be standardized. So one example is in suspension, we're hoping to swap over the fasteners so that there's more consistency across the board. And that'll just help us as a team with systems integration in terms of the CAD and also just like streamlining, assembling and reassembling and servicing the car. Subsystem component swaps should be quick, repeatable, and possible with competition tools. So this kind of came in play to help us decide on like what kind of designs we're doing. We want to have reliability in terms of how we can assemble and repair these things at competition with those resources. So whether we can make them in the shop is one thing. If we can repair them and make adjustments to them at comp is another thing that we think is really important, especially because we want to service these things and tune them so often. And then the other thing is that all data systems should be accessible from a centralized collection process. So I personally don't know a lot about CAN bus, but I'm going to talk about it in a second. And Sienna might talk about it, or other subsystems might talk about how their data collection is going to work. But speaking to the electronics team, we're trying to have an underlying goal of collecting all the data through a similar process. The first iteration maybe, we run it with like the NI DAC box with a computer or with an Arduino, but overall there's still like an underlying goal of trying to have all of these systems and data collectible on the car while it's running. And like the final goal is to establish that process initially so that we can collect all this data not only here on the track but also at competition, and that all of those collection systems will be rules compliant and they'll pass through tech. So that's one of the underlying things that we're trying to work through. Because obviously we can't get hit all these adaptability requirements without being able to test them, and we want to test them in all conditions. So that's what we're trying to work on right now in terms of serviceability and how it relates to data acquisition and electronics. So here are a couple of numbers for the vehicle level specifications. Our car currently weighs, I think it's around 468 pounds. So our goal weight is to maintain that with any changes that we have. And I say less than because it is a good, byproduct if some design change reduces the weight. But right now we're using this to kind of constrain the designs that people have and also any changes that they might want to make. So that's kind of like the design space envelope for each of the subsystems. And we have those in the design posters as well, and people will probably speak to those in their vehicle level specifications. Goal acceleration time is still 4.25 seconds on pavement for 100 feet. So that the way that we calculated that last year was looking at the performance of those top teams and then trying to figure out exactly what we want out of it. This informs what kind of gear ratios that we use in the car, and then also it's going to inform what our goal is when we do testing for the transmission in terms of the tuning for the flyweights or for the belt tension. And our slow turning radius of 11 feet is still one of the things that we're working towards. And then this is just an example. Drivetrain and suspension will probably speak to it more, but I put approximately 3 because I don't know realistically what we'll be able to accomplish, but arrangements for transmission tuning or arrangements for ride height and dampers for the different events should be tested and validated through models that we have, and also any data that we collect. So I'll speak to this later, but we're trying to work on a vehicle dynamic model and to accurately kind of like do a vehicle level analysis of how camber and toe changes and plunge changes, and also just like how vehicle handling changes over different obstacles, and actually model that so that we have something to compare it to when we collect our data. Here's the overall vehicle CAD that this is what the car, well, I can't really say this is what it looked like, but this was the design that we had for the competition in South Carolina. And then I guess I don't really have much else to say about it, but yeah, okay, I'll just go to the next slide. For current vehicle level testing, these are some things that we did and presented in South Carolina. So one of the major things that we did at a vehicle level was jump and drop testing. So this year for the drop test, we placed accelerometers on the chassis and the suspension components, as well as strain gauges on the trailing arm and joints of the rear bracing. So what we've gone from that is not just vehicle level stuff, but more, it breaks down to frame breakout models. So taking those joints and looking at what the stresses are and trying to compare that to the line models that we have. And then also the modal analysis that Benzier does every year on the frame is kind of to check the accuracy of how well we've manufactured it. So it speaks to everything. It speaks to the serviceability, it speaks to the durability, and also kind of gives us a baseline for what load cases we're looking at, but we're trying to expand on that a little bit more. So the drop and jump load cases have helped us immensely with trying to determine suspension and frame loads. So one of the things that we tried to focus on and hit on at the competition in the design presentation was correlation of these things. But we're looking to find more data and ways to collect this data so that we can put them into like a vehicle level model rather than collect data on a vehicle level and then do subsystem level analysis. So vehicle level analysis, one of the things that we've really hit on this year is steering, drivetrain, and suspension interference models. So in the past, as some of you might have heard, we've had issues with engagement and disengagement of the axles. So this year, we really try to take advantage of the ferro arm or the coordinate measuring machine to collect data on the interfaces and the points in space on the as-built car. This also has helped us to do suspension and steering mechanism models, whether that's before they're manufactured or after. We validate both of those things and try to use them to present to the judges like this is the accuracy of our manufacturing process and this is what we deem as acceptable as a team, or like are we going to iterate on this because we face this issue. One of the other things that we're working on this year is using the interference model to guide kind of material removal on the yoke geometry. So one of the things we're trying to prioritize based on our goal of adaptability and also our like specific numbers for steerings and the vehicle handling. We want to kind of access more of that steering motion on the rack. And the thing that's been limiting us is the yoke geometry. So we're using the mechanism model and the interference model to guide how we'll remove that material. Then we use the finite element model to check if those things are failing. And then I don't know, drivetrain will probably talk about this later, but they have set up to test the strength of these designs as well. Yeah, and then reduction of yoke binding for more steering motion. That's what I was trying to get at. The steering and suspension mechanism models. So through the range of motion, we can understand the geometries that reduce things like bump steer, reduce excessive toe and camber change over the range of motion, which are things we're really interested in because sometimes we might want camber change through the range of motion, or we might not want to, depending on the event. And we really want to understand that on a subsystem level, as well as later on in a vehicle level, not just the front or the rear, but both at the same time. So getting into like what we're planning for testing and analysis, one of the main things that I've been talking a lot about this year is a wheel force transducer. So Michigan Scientific Corporation is an organization that makes all of these fork and torse transducers. They use a slip ring to measure all of these values, and they have a rental program for Baja SAE. They have an established sponsorship kind of situation going on. So I'm currently in contact with another team. RIT Baja has used their wheel force transducer many times, and we're trying to figure out what the application process is like. based on what their timeline is like on their end, we'll take it whenever we can. But it's a 2-week rental, so as a team, we're trying to organize exactly what we want to do with that time and what data we want to collect so that we can hit every single subsystem as well as the overall vehicle system analysis. There's also an adapter that comes with this from Michigan Tech, and that can be requested through MSC. The testing goals, like I hinted to before, are trying to determine load cases for the full vehicle dynamic model. We can measure the braking torque, which could be used for load cases for custom brake rotors, as well as the caliper mounting. Tire loads are really important for steering and suspension. For drivetrain, ground tire interactions for simulations are really important as well when we're trying to determine like how much friction there actually is between the tire and the ground, depending on what surface we're driving on. And then load cases for going over obstacles will help us to break into the suspension frame tabs for the chassis breakout models. But really, the main goal on a vehicle level is to get values on how our vehicle handles over different obstacles, so that we can compare that to a full vehicle dynamic model. And then on the left image is a shock dynamometer test and report. So we're looking to get this. It's only $20. We're going to ask for a sponsorship, but one of the things that the judges pointed out was trying to just understand, like, does your product actually function the way that you're intending it to, is a really good, like, that's low hanging fruit that we can attack as a team, in terms of like, validating that the things that we purchase actually perform the way that we want them to. And then also this can help us understand on a more fundamental level, like, what are we actually doing when we're changing the shock settings? And that goes into the vehicle level model as well as the subsystem level models. And then CVT shift curve data collection with Hall effect sensors. So the electronics team is working with Drivetrain right now to acquire CVT shift curves and also collect data on the rotation of the primary, the secondary, the engine, also the half shafts. Like, we're trying to establish a way to mount these Hall effect sensors and collect this data in a way consistently across the board. And then also, as a byproduct, establish this like communication system that we'll use for all of the future electronics data acquisition, and how we'll collect that information as a team, whether that's like live feedback or just collecting and then reviewing it afterwards. Okay, so team level R&D, I talked about the budget that we've allocated to this. So I'll talk about the picture in a second. So for vehicle level data collection and communication through CAN bus, I might not be the best person to speak to this, but the electronics and data acquisition team is working on development of communication and data collection, a protocol so they can use CAN bus to integrate the sensors and streamline addition of new sensors in the future. So we spoke to a lot of teams. Sienna can talk about this at the end if people have questions, but we spoke to a lot of teams, including like Johns Hopkins and then also UMich, about how they collect data, and a lot of them suggested CAN bus, because as soon as we can get it to work with one sensor, the integration of future sensors makes it just streamlines that whole process a lot better. So we're exploring the use of the like National Instruments data acquisition box, as well as, for the wheel force transducer, we'll also have to figure out a way to collect that data as well. They provide a like kind of like iPad looking thing that will collect the data, but if we want to kind of use that as an opportunity to test our data collection system as well, that's one thing that we're really trying to push. Other R&D projects, chassis and welding fixtures. So we have a person that's in charge of that. She's working in collaboration with Ben Zier, our chassis lead, and then also Miles, our suspension lead, on like kind of having that inside opinion / professional opinion, not professional, but like sorry. She has like that experience to help develop the fixtures for chassis welding, and also saying like what's reasonable and what's not reasonable, things to consider when we're welding things that require a lot of precision. So for things like suspension components, like how we can place the tabs and hold them in place that will allow us to hold that accuracy, but also make it manageable for manufacturing. Um, and then one other thing that we've been looking at is usability. Ergonomics and brakes have a seat and pedal jig that they've been working on. And in terms of adjustability and adaptability for that team, it's more so on the sense of like how can we be accommodating for different drivers in a seat sense, and then maybe for the chassis we don't have to be as accommodating. Um, but yeah, so that's what the picture is. There are a lot of other smaller R&D projects on the team that are kind of working on in the background, but these are like the high level, like front facing things that we're working with every single weekend, trying to establish these processes and also establish like a communication passage for the team, whether that goes from me to someone or from Aiden to someone or from a subsystem lead to a new member or someone who's trying to start a project team. So the research and development projects have been a really good way for us to get people involved and also curious and give them kind of some autonomy into looking into those things. This year we have three independent studies through Professor Mir. So Tyler Liao, our previous chief mechanic, is currently working on gear manufacturing. I don't know if this is accurate, actually. I just wrote this up, but so he's working on developing a gear cutting procedure on the horizontal mill. And the idea behind this is it's gonna help our team rapidly prototype drivetrain components and kind of uh remove that dependency on the sponsors and on Professor Mir, and move to more in-house manufacturing. So whether that's for prototyping or just for making like a crap ton of spares, this process is kind of what the goal is. And then from Khan, we have working on like CVT development, whether that's the shift curve stuff or trying to model the transmission mechanism in general. So that's been one of, in addition to just trying to collect more data, that's another pushing factor that we have right now on establishing a way to collect data on the CVT shift curve, and then also, as a byproduct again, um, establishing these communication protocols for the electronics team. And then Darren Chen is working on custom shock manufacturing. So this is a research project on custom air shocks and the design process. So there are a couple other teams that work on this kind of thing, but in general, we're just trying to understand exactly like what shocks we're using, and then also how maybe we could possibly explore custom manufacturing process, or maybe as a byproduct, like how could we modify the shocks that we have now to kind of adjust them a little bit more, which is what we're trying to essentially accomplish by designing custom shocks. So whether that goes to full custom from like start to finish, or whether that goes to modification, that's what Darren's working on right now. So those are the three independent studies that we have through the mechanical engineering department with people that are members of the Baja team. This is separate from the funding that we've allocated to the research and development projects. Okay, so progress and deadlines. I included another picture from the same thing. I did not realize that. But yeah, so seat jig and new placement of Excel and brake pedals, that's something we're currently working on right now. We have final design reviews scheduled for the second week of January. That's something as a team I don't think we've really like done super consistently, but I think what we want to do is we just want to like gather all the alumni up and then say, here's what we've actually done over the entire semester. And then right before we kind of jump straight into like continuing manufacturing in the spring of like those really critical components, we have this final design review to check in with everyone. Yes, and then in terms of addressing those like major things that we talked about at the beginning of like things that are really at the forefront of we got to get this fixed, the dented footbox tube cut and bent. So we have the material, it's bent. We're going to start working on the fixture, and then we have this overall team goal of having all frame welding complete by the 23rd of February next year. And then all manufacturing and testing of the full vehicle assembly is expected to be the beginning of March. And the reason why we have these dates fixed in and have these smaller internal deadlines is so that we can not only test and have confidence in our spares and our manufacturing in the processes that we've been using, but also because we have a frame and suspension component painting, which is a new sponsorship that we've gotten that's going to happen the week of spring break. I think that's what 3/9 is. But yeah, so as a team overall, we're using a Gantt chart to organize our schedule, but on a smaller level, we've been trying to establish like smaller deadlines, goals, and dates that we have just so that we can keep everyone in check and like check in on these projects on a more regular basis. And then having these like, we want to do mock tech before we send the frame and suspension components off to getting painted. We want to have all this manufacturing and all this assembly tested and done beforehand. These are like, yes, maybe the goal is so that we can get them painted, but they really help us to kind of push our manufacturing and design timeline in a way that is realistic to like what a real product would be in the real world outside of a Baja team. So that's what we're trying to establish. Um, and then again, I hinted to this, not hinted, I literally said it, but in the beginning, I talked about the competition that we're attending in Rochester, New York. So this is going to be June 11th to 14th. It's in Palmyra, which is around like 30 minutes from here, I think. Hogback, like Park or something. I don't know what the address is called. Anyways, I'm getting sidetracked. So yeah, June 11th, 2026, open to all members who can make it. We're trying to work out the logistics. We're already registered for this. And then yes, I said this, alumni who would like to volunteer or attend, please, please, please reach out to Ruby Purkis, whether that's through the email that's on the website, or you could email the Baja email as well. And then we'll be attending Octo Baja in October of 2026 to kind of come back to, I mean, that's a really good tradition that we've been trying to keep up for the past couple of years. And the Clarkson Baja event kind of helps us to get into that flow, especially with us building a new car. It could be the fourth competition that this car goes under, and really we like try to solidify these like data acquisition processes, the collection, the communication, how we function as a team in terms of strategy for a competition. Octo Baja is a really great way to do that. And also it really helps us to like reel in these new members that are excited about learning what Baja is. And then subsystem PDR dates, I'll send them out with the presentations on Sunday. So following the week of Thanksgiving, we're going to complete them all that week. Yeah, so the overall vehicle design review, these slides, they're updated since I last sent them out. But the dates for the subsystem level presentations will be on there in the email. Presentations, PDFs will be sent out Sunday, 11/23. Wait, yeah, November 23rd at 6 p.m. So every subsystem will have a presentation, a PDF that's sent out in one email to everyone. Is there a typo on slide? Oh, did I put 36? Okay. All right. Thank you. I'm not very good with numbers. So yes, so every single subsystem, so exempting electronics, which will be a part of every subsystem's presentation to the extent that they want it to be. There's drivetrain, suspension, which includes brakes and steering. And then there's ergonomics and frame. Yes. Sorry, Benzier. So those are the four. And each presentation will include a slide at the end with important questions or concerns that the subsystem leads want to address. So I know, like, speaking from experience, these PDRs kind of can like stretch out really long. So I just want to put a slide at the end of every single person's template that is like, here are the questions that I need you to help me with. And so once those get sent out, I will indicate exactly where it is in the presentation with respect to the last slide, because it should be the same for everyone. And then if you guys could please check those out. I sound like a YouTuber. if you could take a look at that slide, if you here, this is what I said. I'm just gonna read it out. If there is any slide to take a look at beforehand, it is that one. So that would really be greatly appreciated by me and by all the subsystem leads. So keep an eye out for that one. Okay, questions for alumni. So I know I've dumped a lot of information on you guys. What I want to ask, one that's more of a heavy, like, I don't want to, load up the question, but advice in general on what more vehicle level testing could look like. So from you, the professionals, what does that look like? One thing we really struggled with is like, we do this vehicle level testing and then we take these numbers and do it on a component or subsystem level. And the judges don't really like see that as an answer to the question they're trying to pose for the vehicle level presentation. So some judges mentioned vehicle level durability analysis. I don't know when I wrote this, but I said not sure how to attack this. Vehicle level dynamic models, those are the things that are like right at the top of my head. I'm like looking at that right now. We're looking at that as a team. We're trying to attack that with a wheel force transducer, understanding and characterizing the shock and damper values. And then I guess, yeah, if there are any suggestions on that, I'm just gonna like read this whole thing out and then we can have a conversation about it or go back to any slides that people have questions about. And then on a team level, obviously our performance on the cost reduction and the cost event was not great. So I just want to ask if people had advice on how we can support the team and get people to fill out the forms effectively. And also, how has it been done in the past? Like, I think as a team, fundamentally, we're maybe misinterpreting what the cost event goal is. And I don't know if it's the same as how it's been like over the past 20 years. But our understanding now is that it is what would it cost Polaris to build our car? And so I don't know like if people could speak to that directly or in general, people just had advice on like how do we really keep track on like cost reduction and how can we possibly like organize it in a way to get on a team level everyone to fill these things out effectively. Um, okay, that was the end, but I'm gonna keep it on this slide because I want to hear people's suggestions. And then Ruby's keeping an eye on the chat, so if you don't want to speak, that's fine. But if you would like to, that would be nice too. But yes, thank you to everyone who came. Feel free to leave if you need to. I know it's late and it's Friday, but I will be sticking around for a long time if people have anything to say. Also, if there are any suggestions on what to include in the presentation and what you want to see in a vehicle level PDR, that would be incredibly helpful as well. Yes.
Hi, this is Leslie Johnson. I graduated in 2014.
Mhm.
Um, and I said two things. One, first of all, excellent presentation.
Thank you.
To your question of what I'd like to see in a presentation, I
Yeah.
think it would be really valuable to see like a single slide with a concise list of what changes are you making, right?
Yeah.
You
Okay.
talked a little bit about, like, you talked through them, I think, overall, but I'd like to
Mhm.
see the specifics of what are you changing and
Yeah.
what drove you to decide on those changes.
Right. Okay. Yeah, that makes
Um,
sense.
yeah. As for the vehicle level testing to be conducted, I don't necessarily have a great recommendation for what to test. What I would think about is what are failures that you've seen, even like the dent during S&T, and do you understand what caused it? And is your testing representative of actual conditions that the car is seeing
Right. Mhm.
throughout competition, right?
Mhm.
I think I'm sure that every year there are failures. So do you understand what really caused those? And are you able to test in a way that gives you information on whether the car this year can survive something it saw last year?
Right. Yeah, one of the things we've struggled with is trying to like pick and choose what obstacles we can actually design to. So in terms of like that specific, like really not catastrophic, it wasn't catastrophic, really like intense failure that we saw from denting the frame. Like one really big discussion we had as a team was like, could we possibly predict that happening again? And is that something that we can actually design to? So that's what Benzir has been trying to work on. But yeah, I completely understand and I agree. like trying to see if we're actually testing in a way that answers a question of like, can our car run through these competitions? Like that's what we're trying to do. But I think it's kind of fuzzy right now. So that helps a lot. Thank you.
Yeah. But I'd also say, right, that the way you're thinking about it is good because you're not just saying what happened and can we prevent it. You're also thinking about what happened and is that actually going to happen again?
Yeah.
Or is it just a one-time deal?
Yeah.
So, yeah.
Yeah, so one of the other things that I talked about a lot was like trying to develop a vehicle dynamic model. So the goal behind that is like if we could set up really simple obstacles that we could recreate in a model and then have like the whole car as a system drive over it in the model and then also drive over it while we're testing with the wheel force transducer, then like we can actually like say, okay, we trust our model this much, or it's within this percent of what we actually collected for the data. Whether we're successful with the wheel force transducer the first time around or not is another question, but I think I'm feeling optimistic based on what other teams have said in their Discord. But I also need to just like contact someone to make sure that we set it up correctly. But they're really open to that, so I'm excited to see where that goes. Are there any questions? Nothing in the chat? Okay.
Hey, this is Mike McFarland. I graduated in 17. Just a follow-up question about the durability thing.
Yeah.
Was the feedback you were getting, the judges were looking specifically for some sort of durability analysis, or were they just
Yes.
looking for more? Okay, so it wasn't just tell
Yeah.
us how
So
you're okay.
yeah, they literally said like we want to see durability analysis on a subsystem level and also in the vehicle level. So I guess like I don't know if I've been looking at the right resources into how exactly we could do that because on a vehicle level, I think it's harder for me to understand like how we could measure it. I know for drivetrain, it's a little bit easier. Like they could do fatigue analysis on the gears, or once we solidify like these loads for the chassis, like trying to do like a durability analysis of the tabs. That's one other thing that we could look at. But I guess on a more broader level, like I really don't know what kind of things could possibly fall under the scope of like a vehicle level durability analysis. I don't know if you had anything to add to that.
I mean, everything you and Leslie were just saying sounded like the right path to me as well.
Hmm.
I guess I'd also suggest just don't get too hung up on have analysis to have analysis. So,
Yeah,
make sure that whatever you do wind up doing is actually going to be helpful. And I guess
yeah.
one suggestion I would have too is, analysis doesn't always have to be FEA, math heavy stuff. It could also be, one example, think about where the car might have to deal with impacts, what specific components might be more vulnerable. Like
Right.
maybe you have some special rules that you look at on your lower A arms or
Hmm.
where the steering links are located to protect them from impacts. And
Yeah,
you can sort of have a quick, like one pager that says, hey, here we thought through where we laid out how we arranged certain components on the car to
yeah.
protect them from impacts. That could
Mhm.
be something else too.
Okay, yeah, that's great. Yeah, because I think like especially we've had a bigger conversation in the last year when we were designing the car about having the steering mounted to the rear of the upright instead, but in terms of packaging and trying to be able to like accomplish, work with the differential that we currently have. And then this year, the drivetrain team is pursuing a custom differential, but they still want to have that kind of fallback of like we can put in the Hilliard if we want to. That's also limited the packaging that we've had, but definitely in terms of like durability, yeah, I think if we can include that as part of the conversation of exactly how we mount things to the upright, or literally even just like we check this too. That's a really great point. On top of like saying we put these things here because we want the mechanism or the dynamics of the vehicle to be this way. So yeah, thank you for that. This is here.
Hey, hi, this is Gordon Hall.
Hello.
Hello. I graduated in 98 and went on to finish my master's in 99. Um, so just want to congratulate you, the team. You are, it's like comparing what we had as a flip phone versus like the iPhone 17.
Yeah. Thank you.
So yeah, it's very impressive. Excellent presentation.
Thank you.
And overall, I think you guys are, this is regardless of how the competition results, you are all learning a very valuable lessons on everything from design, analysis, manufacturing,
Mhm.
testing, validation. You know exactly what you know your goals. Um, Very excellent project management from what I see. This is exactly how in a real world a project is run. And I'm in the nuclear power industry, and I work on large projects that has many different aspects, different components. This is exactly like I can see you guys jumping into a real world project with no problem. So this is a very good to see how you guys are doing with this project. Yeah, employers love to see these qualities. Like
That's great
I
to
would
hear.
hire you guys, any of you, I would hire you in a heartbeat.
That's great.
So, yeah, I don't have any advice or anything, but yeah, very.
Thank you for coming. I mean, even if you don't have advice, that's great. I'm glad that we have all of your support. Um, yeah. Does anyone else have anything to add or anything?
Sure.
Maybe, I guess, someone commented, I don't know if it was you, about the date. So hopefully we do have all manufacturing done by 2036. But yeah. So yes, Leslie, thank you for saying, adding stuff on, like wanting to see a slide. That does help me a lot. I wasn't really sure how to format this thing, so that helps a lot. Sorry, I'm flashing everyone with the slides.
Yeah, and we'll definitely take that into consideration for the subsystem PDRs.
Yeah.
We'll add a slide for that, and then
Yeah.
also for final design reviews, we'll add that slide.
Yeah.
Chaz is here, I think, and was
Oh.
unmuted.
Yeah, sure. Can you guys hear me all right?
Yes.
Yeah, I was gonna add on to what Gordon was saying too. That was my first impression. Great presentation skills, Natalie. It's hard to come by like those kind of speaking skills. You stayed on topic on everything, always bringing it back to, this is what the judges want to see. This is what we saw in competition, which is great. I think you guys are focusing all on the correct areas with spares, your fixturing, things we've always talked about trying to focus on, but really drilling down on those. So I think that's great. I forget what else I was gonna say. Oh, for ideas, yeah, the durability analysis. Are they just talking about like fatigue analysis or
Yeah,
just
so I know on a subsystem level, it was like a reoccurring theme. They really wanted to see like fatigue analysis. And I did overhear like there was a team in front of us in the engine check line. They were like, yeah, I ran the analysis for this thing to run for 80 hours. And I was like, okay. But like, I guess, I don't know. My impression is that for like gears, it should be pretty straightforward. For other stuff though, like the loading is so different. I don't know. Am I supposed to do like a front impact load like 50 million times on the lower AR? Like, yeah, I don't know. On a vehicle level, I'm really like kind of stumped on, and I'm sure we could ask other teams, but I don't know if you guys have done anything like that in the past.
not in the past, but I know fatigue is great. I've always talked about the team. It would be great to get to some fatigue analysis. And
Yeah.
I don't think it's too tricky with FEA, but adding on to what Mike McFarland was saying, like I definitely agree. If you can run a test that gets your result quicker,
Yeah.
if you can drive, it's great this year you have the car's running now, right?
Yes.
Yeah, that's great. I know in the past we haven't had my year, my year we never had that. So just seeing you guys in the last 2, 3 years has been exponential growth in the competition results and resources. So it's amazing to see. But I was gonna say for one of the tests, I don't know if you could go off like a 3 foot jump, 100 times, 200 times, if you're able to work with RIT, something like that, doing
Yeah.
the same jump 100 times, seeing what fails,
Mhm.
doing the test again, see what's the next weakest link, fix one thing at a time.
Yeah.
Or something similar to that. Like you were saying with that frame member,
Mhm.
that frame member gets busted every single competition. I don't know if we've ever ever gotten that like super successful. So that,
Yeah.
if you did some testing around that, drive the car 20 miles into a rock safely.
Yeah, so actually I'm gonna spoiler alert for the frame thing, but Benzir has been talking about taking Genesee's frame and kind of constructing a pendulum and like throwing it into a wall to see if we can recreate that impact. But yeah, for sure, like the jump that we came off of that destroyed that front member was a like, huh? Oh, it was the rocks? Oh, I thought that's when the frame like landed like
No,
like that.
10 miles, not even
Oh,
full
10
throttle.
miles. Okay.
He just hit the rock, like not
Yeah,
even.
it sounds
Okay,
right.
I see. I thought that's when we were in S&T.
Yes, it
And then
was.
she went like that.
No, she did beautifully on the jump.
Okay. Okay, yeah. So if it's the rocks, then like that's definitely more reason. But they're like, I don't think I've ever seen, I don't know how tall that cement block was. It was like over 4 feet, and you just like drive right over it. So yes, I know RIT has some crazy stuff like that, and we'll definitely be checking that out. We did a track
But yeah,
walk
in
like
my
last
mind
week.
for durability, it's just number of cycles. So whatever
Yeah.
test you can do with number of cycles.
Yeah.
I can talk more during the drivetrain PDR. I
That'd
know
be good.
some testing you could do that is for like that is like reducing the moment of inertia of the drivetrain. That's something probably easy to do in simulation, and then
Mhm.
actually measuring the rolling resistance. I'm sure we did that in the past. I think Arthur did too at some point, but
Mhm.
see, we keep reducing the rolling resistance of the entire car.
Yeah.
Interesting. That's just off the top of my head. I'll try and think of some stuff
Yeah,
before
that would
the
be really good.
drivetrain PDR.
Mhm.
But other thing, maybe not so related to this exact presentation, but is there any tools you guys are using besides a work breakdown structure or anything for delegation? It sounds like you have a
Yeah.
great team.
So Aiden and
Um,
I are gonna meet with, well, I actually haven't talked to Aiden about this, but Professor Muir, yeah, to do a work breakdown structure. Last year, I think Tyler and Ton did it really well. We had it like on a subsystem level, and then Tyler like accumulated all of it together to kind of see where the bottlenecks were. And I think that would be really helpful, especially because we have these really like not high stress, but like these dates that we really have to meet in terms of like, if we're going to have this wheel force transducer and we know what date, we need to know what the bottlenecks before that are going to be, or like if we need to have the car running by this date so that we can check everything and then send it off to get like painted, then like yeah, work breakdown structure. That's what we've been working with, and then we have a Gantt chart to schedule stuff. But I don't know if you had any other suggestions for like other things, because in terms of like organization for dates, those are really the only things that we've been using. And I don't know if there's something that you prefer personally or like you think might work better.
it is the hardest part of any project,
Yeah.
including the professional world. If we had a similar team, this would probably take us 2 years or something to do what you got, what you're doing.
Yeah.
But it's good you're learning these skills to go quick because it's good in the real world. I'm sure Mir will talk about critical path management. I guess that's how I would think
Yes.
about it.
Yeah.
Because that's what always happened is like, all right, the frame's ready for tabs, and then there's no tabs for the next 3 weeks, and
Yeah. Yeah.
so unfortunately there's never like a secret thing. The main thing is I would say is just who's responsible for
Yeah.
each. If you're delegating it out, you have a lot of people, which is great. But yeah, just making sure who's responsible for what thing and what time, and
Mhm.
that's the hardest part. But I mean, you got the right headspace around it.
Mhm. Yeah, one of the like kind of underlying goals behind trying to pyramid structure the team a little bit more is that there's kind of like, maybe smaller project teams, but the subsystem lead is kind of like the point person. So I think that's been going well so far, like in terms of me and Aiden checking in on people. But when it's like smaller projects, we're kind of losing the information a little bit. So definitely like trying to get the work breakdown structure thing down as like a fundamentally as a team, we will always do this. I think that's one of the goals that we should have this year for sure. And the
Got it.
critical path management.
Yeah, I guess, yeah, my only suggestion, I guess, would be is if the chief engineer is kind of, overseeing all that, build a system that, works best for you,
Mhm.
because it works differently for everyone. So,
Yeah.
some people prefer a massive Excel, some people prefer, Visio or something, but you don't have to, I'd say just don't overcomplicate it,
Yeah.
but no, that's sweet. That's my main piece of advice to try and figure that stuff's always the hardest to figure out. I'm not
Yeah.
good with that.
Yeah. I think that was the other thing, like it's almost I mean, I would say they're analogous to each other, but like in terms of like the cost reduction report, I guess well, things that we talked about over the summer is like, can we get people to not just like, people are putting in purchase requests and stuff, and then that gets logged in a spreadsheet, but like if we can set it up in a way that people fundamentally also in the back of their minds are like, okay, I'm going to make this part. This is how much it costs. And then they're always like thinking about that or have it documented somewhere. I guess I could totally look this up, but like if there's a way to integrate that somehow into how people organize and like keep track of their design stuff, that would be great because then when we sit down, we actually have a day planned in the schedule where we're all gonna sit down, lock each other in like Hopeman basement and do the cost reduction report. So that's where I'm at right now. But I don't know if you guys have any advice on like how realistically you could do design and then also at the same time like always keep track of like what the cost of something is besides like just the purchase requests, I don't know if it's kind of a loaded question.
How good is your like drawing structure in the last 2 years? Have people been making drawings for each components and everything?
No, it's not that great.
Okay.
But yeah, I guess that makes sense. Like if we could
I
put
was
it,
wondering you could mandate like on the
yeah,
drawing, like, what's the cost that, you can just go on
yeah,
online metals and just say, all right, this brick of steel, costs this
yeah.
much
Because I think one of
for
the other
like
things
those
is,
components.
yeah, it's like you make the design and then like a month later you're like, holy crap, I need to buy like this huge chunk of aluminum. It's like, I mean, that's
Yeah.
literally happened, but like if people could think about like not just the design, but like the stock part that it comes from, that
Hmm.
would be great. Even if they just did like a, like a bounding body around it and they were like, okay, this is what I need. Because I
Are
don't
you
think people
guys
were thinking
tracking
about that.
hours spent?
Pardon, what was that?
Are you guys tracking hours spent uh
Oh,
in
like hours
manufacturing
spent on designing something and manufacturing something.
or
We don't track that, but part of the cost report is like the different manufacturing processes. So one thing that I think it does make sense, they're trying to frame it in a way that's like, how much would it cost like us to mass produce your car, not how much would it cost you as a team to like
right?
prototype it. So they do things like for the chassis, especially like you have to calculate the length of all the welds and then you assign a value to that based on how much they say, like 15 cents per centimeter of weld or something. I don't know what it is exactly.
Okay. I want to circle back to I hear you talked about fatigue analysis.
Yeah.
So fatigue, uh, it's when I think of fatigue, I think of purely in the analytical sense that you just calculate the stress range and divided by half, that's your alternating stress.
Mhm.
That's how like if you're bending the paperclip, right?
Mhm.
Um, so that's your alternating stress, and you can ASME Co has a fatigue curve for alloy steels and
Mhm.
stainless steel. You can take your alternating stress, go look up in that SN curve and come up with the allowable cycles.
Yeah.
So that's your fatigue.
Okay. Yeah, that's good.
So
Like a base level we
yeah,
could do.
yeah, and then the thing is then you need to figure out how many cycles you would your vehicle or this component would be experiencing this stress level.
Hmm.
So that's something that you have to uh, postulate.
Yeah.
So that's the fatigue analysis that it's pretty um, you know you have to postulate your events.
Yeah.
So I think they can't say it's a it's assumption, so they
Yeah.
can't say that you're wrong. But
Yeah.
that's
Yeah.
a simple fatigue analysis that you guys can do.
Hmm. Yeah, that's good. Because it's not like we need that much extra information just to do the analysis, but I guess the
Yeah,
part is like how can you the assumption that you're making. That's one of the other things. Like the judges are really like, what assumptions are you making?
yeah.
And then like when you
You,
collect this data, like are those assumptions still like one of the things they said was um I want to know what assumptions you're making, why you're making them, and then after you get the data, if you feel like they were valid. So,
yeah.
yeah.
So another thing that we sometimes use for fatigue is if the stress level is so low, it's so steel has an endurance limit. So uh, so that's a if you are below that endurance limit, your stress level or your stress range, then that means this component can endure infinite number of cycles.
Yeah.
So um, so that's something that you can look at if it can indeed endure. So like stuff like vibration,
Yeah.
vibration of a pump. So uh, the reactor coolant pump could be it rotates at I think it's 1200 RPM. So over the life of the power plant, it just spins, right? It has an infinite number of cycles, so
Mhm.
we have to keep the stress level at below the endurance limit,
Mm,
for example.
see. That's good.
As Nat mentioned earlier, we're not going to have a designated PDR for electronics, but it will be integrated in the
Yeah.
other subsystems. But Sienna's actually on the line right now, our data acquisition and electronics lead. So I was wondering if anyone has specific questions for data app. Cool. Okay.
Do you want me to talk about it at all? I know, Nat, you said that I might talk about it at the end. I won't take extra time if it's not necessary, but
I
I'm
guess
here if
maybe
you
you
want.
you could just say like one or two, I guess maybe not one or two sentences, like a little bit about like how you're trying to what kind of like goals that you're trying to instill in all the people working in electronics because I try to talk about how
Mhm.
we're trying to have like consistency across the board. But I guess if you could say like, you know, we have I don't know how many projects you have right now, like six maybe.
Yeah, something like that.
And then like I don't know if you want to talk about what you where you guys are at with CAN bus. I don't know
Mhm.
if people are interested, but you could I would just go ahead and say something about it because Colin is here.
Yeah, I'll just talk briefly, I guess. I mean, I would say the biggest update with electronics and data act for this year is just growing the team. So instead of it being one person, there's now I would say probably 8 to 10 people. I hold like weekly meetings and have delegated projects. And there's like a good group who are consistently coming, and that's also extending to like Con and Tyler have done work with like some of the testing and some of the like mounting and stuff too, and kind of getting new members involved in that, which is also exciting. So yeah, I would say the priorities are, oh, the other thing is that in the past we've had problems with like the infamous like data person makes a 3D printed mount and it vibrates. And so that's like a something I've realized is that actually one of the hardest parts of data act is the mechanical part. And so that's been great to have like Con and Tyler on board for that. In terms of the CAN, so we ordered just like on Amazon a plugin module that will work with the Teensy microcontroller we're using. And from there, one of the freshmen is she worked with some CAN in robotics in high school, and so she's kind of spearheading that project and working on it. We haven't made a lot of progress yet just because we haven't actually gotten the module yet, but we should have it by this weekend, I think. So she's going to take a look. The goal of that is number one, it's a method of like sending communication through cables that is much more robust than other versions, robust to noisy environments, which driving a Baja car is very much a noisy environment. And so that's one benefit. And the other benefit is that unlike other methods of communication, like I don't know if anyone knows about UART communication, but then you would kind of need to just like speed up, like rapidly speed up how fast you're sending information instead of kind of sending it I want to say simultaneously, something like that. So it's much easier to expand to say like, oh, hey, 3 years from now, we've got like 20 sensors on the car and we can send them all through the same channels. So those are kind of the things that are going on.
Yeah. And then on a subsystem level, I think we're not expecting Sienna to go to every single one, but if you have questions about like how data for those tests on a subsystem level specifically are being collected, and it's not through the subsystem lead, but through the electronics team, then definitely I would say reach out. The other thing that we have is a spreadsheet of all of the like design and manufacturing people. So I will send that out today or on Sunday with all the presentations, because at the beginning we have a like the first slide, it says like who the subsystem lead is and then the project team leads. So there's contacts there, but we have a spreadsheet as a team that keeps track of like all the people and then who they're under and like what's the best way to contact them. So I'll send that out in case people have questions or want to follow up from the meeting so that they know like who was talking during the presentation or who can I ask or talk to more about this thing that they were concerned about. I think that'll be helpful, but I'll send that out. Yes.
Anything to add as we wrap up?
Okay. Well, thank you everyone for coming. I sincerely appreciate it. You spending an hour and a half on Friday. It's Friday, right? Listening to me talk about this and giving us advice. It is genuinely extremely, I don't know how many adjectives I can use, but very appreciated. Please feel free to reach out or contact me if you have any questions or if you notice something on the presentation that's like egregiously horrendous. But I will be sending out the notes that Ruby took, and then also we're gonna try to record all of the presentations unless there's an issue. The captions should be on as well, so everyone should be able to see them. And yeah, the slides will be sent out. Subsystem level slides will be sent out on Sunday, and then we'll have the schedule for the subsystem level thingies too. Sorry, not thingies, presentations.
From a technology perspective, could you see the screen? Could you hear us well throughout the presentation?
Yeah.
And also, could you see the captions?
Yes.
Great.
Yes.
Fantastic.
Yes.
Awesome. All right. Okay. I think unless no one has any dying questions at the end or concerns, We will end it there today. Thank you again so much for coming. I really appreciate it. I hope everyone has a fantastic weekend, and I hope you're looking forward to my email. Yes, thanks everyone. Have a good night.
Thank
Good
you
job.
guys.
Great work. Thank you.